So, the star Sirius, the brightest in the night sky, is 8.6 light years from Earth. If you traveled in a ship at 0.8 C, an observer on Earth calculates that it will take you 10.32 years to get there. How long would you measure it to take? So, time dilation is this equation here. So again, this equation is time dilation. Now, let's go ahead and talk about what each of these symbols mean, because there are 4 of them, and I want to make sure you know what they stand for. So, let's start with the easiest one, V. Okay? V is the relative velocity. Of an object. In this case, and I'm going to do my knowns and unknowns at the same time. In this case, the relative velocity is that of the spaceship. That's the observed velocity from an outside perspective. It's traveling at 0.8 c. So that's the relative velocity of an object. Okay, the next easiest one to understand is c. C is the speed of light. At this point, you're probably expecting me to give you the value for the speed of light. Except, I'm not going to. Because you don't actually really need it. I will write it down in case you're interested. And there will be one problem that we'll need it for. But I'll give it to you when you get there. Most of the time, though, we're not going to use the speed of light. We're just going to use c. And believe it or not, the reason we're going to use c instead of a number is because I'm nice to you. That's why. Is
that 1.0?
Say again?
Is that 1.0?
3.0. Times 10 to the 8th. That's the speed of light. Believe it or not, it's actually easy to solve without a number than with a number. Okay. Now we get to the 2 hardest ones to understand. So again, the value for us is just c is just c. C is just c. Okay? Here are the hardest 2 to figure out, t and t naught. Now, it's pronounced t naught, not t0. And it's not to. So let's start with what t is. T is the measured velocity, or sorry, the measured time from an outside frame of reference. In other words, this is what someone not on the spaceship measures. Right? This is the relative velocity. So the spaceship is going 0.8 c relative to some outside observer. That outside observer is measuring their time from an outside frame of reference. T naught is called the proper time. Or some people like to think of it as the correct time, although Einstein would argue there's not a correct time. But it's the proper time. So from the object's frame of reference. So v is how fast is the object going. C is the speed of light. T is how fast do I, on an outside reference frame, measure the object to do. And T naught is what is the correct or proper time someone on the object measures. Here is what's hard about these problems, figuring out T and T naught. Once you figure that out, you are going to be golden on these problems, honestly. Once you can figure out what's T and what's T naught, the math becomes much simpler. And it's just, can you do the algebra? And on this unit, I am super, 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 super giving on the partial credit, right? So if you set it up and you just don't get the right answer, but your setup is correct, I'm going to give you at minimum 4 out of 5 points just by doing the setup correct. Knowns and unknowns, plug things into the right spot. If you do that and bomb the math, you'll get a 4 out of 5. because I'm thinking in my head, what is a B quality work? So B is better than average, but not like great. Okay, it's good. B is good. What is good for me on these problems? Good is you know what the knowns and unknowns are, and you can plug them in. Do I want you to get the right answer? Of course. If you don't get the right answer, am I going to be upset? No. So you should still get a good score if you don't get the right answer. So make sure you're showing your work and make sure you're doing the setup parts. Okay? So let's see if we can figure out what all these things are. So T is measured from an outside frame of reference. So an observer on Earth calculates it will take you 10.32 years. That is the measured time from an outside frame of reference. So that means T is 10.32. I want to know how long you measure it. You're on the spaceship. That means you measure the proper time, and that's going to be T naught. Now, obviously, I took up a ton of space here just explaining this. If you need more room, there's room on the back. Okay? I'm going to do mine on a separate sheet of paper now to actually solve this. So at this point, it just becomes, can you do algebra or not? And again, some of you have trouble with that, and that's fine. Just do the best you can on them. So let's go ahead and plug things in and set up and solve. So T equals T naught over the square root of 1 minus V squared over C squared. So I'm going to plug everything in exactly where it goes. So T is the measured dilated time. Here we go. T is 10.32 years. All right. T naught is T naught over the square root of 1 minus V squared. V squared is 0.8c. Over C squared. There's the setup. That's what it looks like. Okay. Anyone have any questions on where things went or why I put them where I did? Okay, let's do some math. The first thing I have to do is square V. Now, V is 0.8c, which means I need to square 0.8 and I need to square c. So when I square 0.8c, I get 0.64 c squared. You have to square the number and you have to square the c. The velocity is 0.8 c, so I have to square 0.8 and square c. When I do that, I get this. 10.32 equals T naught over square root 1 minus 0.8 c squared is now 0.64 c squared divided by c squared. And now you can see why I tell you not to plug in a number for c. Because what happens? Yep. If you plug in a value for c, you have to square the speed of light twice and multiply that by point. Oh my gosh, it's terrible. Don't do it. I am always going to give you the velocity as a percentage of light. Always. Always. Unless we're doing a low-speed problem, in which case I'll tell you what the value is. Okay? All right. So now we're ready to go on, so we cancel out the c's. Okay? 10.32. And again, you'll notice I'm going really slow on the steps. You most likely will go faster on these solving steps than I am. I'm trying not to leave anybody in the dust. So I canceled out the c squareds. So now I got 10.32 equals T naught over 1 minus 0.64. So here we go. That's 0.36. Okay? Just cruising right along here. 10.32 equals T naught over the square root of. So 1 minus, there's the 0.36. So now I need to square root 0.36. That is 0.6. Don't you love when Mr. B picks really nice, happy numbers? Not that I did that because I wanted an easy problem to solve. So now we've got 10.32 equals T naught over 0.6. And now we're in the clear, right? Now we're ready to do the algebra that you're used to. Something divided by something else, you have to multiply by the something else. Always multiply by the bottom, so I'm multiplying 0.6 to both sides. The 0.6 cancel on the right. On the left, I do 0.6 times 10.32, which is number 6.19. So here's what this answer means. If someone on Earth measures that it takes me 10.32 years to get there, and I'm traveling at 0.8 c, that means I actually measure it to only take 6.19 years. So how long did it take? Ron? You're right. It took both. It took 10.32 years and it took 6.19 years. That means I on the spaceship am 6.19 years older. Peeps on Earth are 10.32 years older. Okay? So that's how you go about setting up and solving these. Okay? Let's take a short break. I'll show you, like I said, I promised adorable animals to make your weekend nice. And then I'll give